Hi everyone, I've been working with my Commodore 16 and I wanted to make a quick video about this board that I've had recently produced. It essentially lets you take a MOS 6510 CPU commonly found in the Commodore 64 and put it in place of the places where you'd find a MOS 8501, which is essentially the TED series of machines. The Commodore 16, the Commodore 116, and the Commodore Plus 4. Now I'm not going to take credit for this design. The mapping of CPUs was done by Mr. Andrew Chalice of the United Kingdom, and I'll link to his website below where you can get all the information about how this mapping works, along with some of the limitations and the extra ROM requirements. I'll also link to Andrew's eBay page below in the description where you can buy his implementation of this board, and we do want to support him, so please consider purchasing from him first if it's financially feasible for you. If you live in the United States, then you may wish to consider my eBay listings, which I've also linked in the description. At the time of publishing this video, I have a small number of boards remaining, but I may make another production if there is enough interest. Again, check out Andrew's listings first and try to purchase from him if it makes sense for you. Adrian Black also did a video on this subject, and he built a similar mapping device by using two sockets that had shifted pin alignment and some rewiring. And that might be feasible for you as well if you want to build one and don't want to have a large batch of PCBs made. I'll have a link to that video in the description as well. So here's a close-up of what one of these boards looks like. This is the 8501 side, so this would be the side that faces the motherboard. And on the other side, it's just a similar mapping where the 6510 CPU would sit. Okay? So putting one of these things together is fairly straightforward. We essentially are going to utilize some male pin headers for the 8501 side, and we would place those along the 8501 silk screen like so. And of course this side here would fit right into the CPU on the system board. And then on the other side, we could fit a socket that would be 40 pin length socket, or two of these 20 pin precision round pin headers. We can put them in like so. And then you can fit the 6510 in that socket. Alternatively, you can just put the 6510 directly into the board and solder it that way, but I think most of us prefer to have a more flexible solution. Finally, we can also put a 2-pin header into the tape motor footprint, and what this allows you to do is to either put a switch across these pins so you can manually control when the tape motor is active. One of the limitations to using this mapping is that you do lose control of the tape motor from the 6510. So if you don't have a cassette or a data set system to use, then this is completely not needed for your implementation. But by putting a switch across here, you can manually control it, or you can bridge the two pins and the tape motor will always be on. Totally up to you, whatever situation works best. So let's take a look at how we would mount something like this in a Commodore 16. Here's the inside of a Commodore 16, and I've already removed the 8501 CPU. And here's a pre-assembled adapter board. I have a female header on the 6510 side and the male header on the 8501 side. Important to note that the pin 1 of the 8501 side is here, and the corresponding pin 40 is on this side, so that when we go to insert this into the socket, we put it in the correct way. That's pin 40 and pin 1 accordingly. Okay, and then we can line up our 6510 with the notch on the board and the notch on the IC and insert that as well. And we're done. Now I'll take a moment to talk about the clearances that are introduced by having this adapter board. Obviously, this is going to be raised substantially higher than if the CPU was directly in the factory socket, and so that may interfere with the RF shield that comes with these computers. I don't have an RF shield installed because, well, it just gets in the way and I keep opening and closing this thing all the time. For the +4, on the other hand, in the Commodore 116, the elevated stack of ICs might actually interfere with the closing of the keyboard case. If you recall, the +4 and Commodore 116 have the compact, tiny, wedge-shaped keyboard, which is much smaller than the bread bin that the Commodore 16 comes in. So if a stack like this doesn't work for you, then an option that you have is to remove the socket that's already in the system board and then to take the adapter and solder it in place of that vacancy. There's also some additional clearance needed on each side of the board with respect to the socket footprint, and I'll have those clearances in millimeters listed in the description below, so you can measure out in advance if something like this would fit inside of your computer. And that's about it. Quick reminder, if you want to learn how this adapter works, again, review Andrew's website. It's linked in the description below. If you have some friends or colleagues that might find such an adapter useful, please share this video with them so they can get the information they need to either build one of these adapters for themselves or purchase one from the online markets. I'm going to be making some videos about diagnosing and repairing the Commodore 16, so if you want to see those, feel free to subscribe, like, share, do what all those things that YouTube tells you to do so you stay notified on when those videos are available. Thank you for watching, and I hope to see you back soon.